Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is CH3C, CH3, 2CH, CH3, CH, I, CH2, CH3. The quaternary carbon bears two methyl groups, the CH3 at the start of the chain and the substituent CH3. The next carbon bears one methyl group, and the fourth carbon bears iodine. Moving on to the next step. Count the carbons in the main chain. Starting from the terminal CH3 through C, CH3, 2 CH, CH3, CH, I, CH2, CH3 gives 6 carbons total in the main chain. This is a hexane backbone. Moving on to the next step. Number the chain to give substituents the lowest locants, numbering from the end closest to the substituents. C1 is equal to CH3, C2 is equal to C, CH3, 2, C3 is equal to CH, CH3, C4 is equal to CH, I, C5 is equal to CH2, C6 is equal to CH3. This gives substituents at positions 2, 2, 3, 3 methyls, and 4 iodo. And for the final step, the parent chain is hexane, 6 carbons. There are 2 methyl groups at C2, 2, 2 dimethyl, and 1 methyl group at C3, 3 methyl, giving 2, 2, 3 trimethyl. Iodine is at C4 giving 4 iodo. Combined 4 iodo, 2, 2, 3 trimethylhexane. If numbered from the other end, iodo would be at C3 and methyls at C4, 4, 5 locant set, 3, 4, 4, 5 versus 2, 2, 3, 4. The latter is lower at first point of difference to 3, so numbering as chosen is correct. A. 3 iodo 4, 5, 5 trimethylhexane, wrong positions. P. 4 iodo 1, 1, 3 trimethylhexane, positions 1, 1 are impossible for internal methyls on a hexane with this structure. C. 4 iodo 2, 2 dimethylheptane. Heptane would require 7 carbons in the main chain, but the longest chain is 6. Therefore, the correct answer is D. Therefore, the correct answer is option D.